Good afternoon. Welcome to this podcast video. So we will discuss the problem that we are discussing in the class related to binomial distribution. Um, I was unable to discuss it completely in the class because of the time getting running out. So I thought I will discuss the problem here again and do it in a very systematic fashion. Okay, so I will write down the problem. So it's related to a manufacturing process. So a manufacturing process produces 1,000 diodes a day. On an average, 1% of products do not conform to specifications. And 50 diodes are tested randomly every hour and classified as conforming and non-conforming. Find the probability of finding one or fewer non-conformities. Okay, so that is a problem. So we will read this problem very carefully. So it's a manufacturing process which produces 1,000 diodes. So your population size is 1,000. So 1,000 samples are produced. Okay, in a day. Okay, on an average, 1% of these products do not conform to specifications. So percentage of products non-conforming to specifications is 1%. If I write it in fraction, it is 1 by 100, so it should be 0.01, and that is nothing but my p-value. So p corresponds to the success. In this case is actually the non-conforming percentage of non-conforming products. Okay, p is nothing but the success. So in my binomial trial, I treat success as the percentage of products non-conforming to the specifications. Okay, and 50 diodes are tested randomly every hour. So sample size n is 50 samples. Okay, 50 samples are tested every hour and classified as conforming and non-conforming. So you do a test and see that whether the product is conforming or non-conforming. And they found that, observed that there was on an average 1% of these products are non-conforming to the specifications, and this p is actually a constant. Okay, p is not changing. This is an average value. Okay, average value, and that is assumed to be a constant. Find the probability of finding one or fewer conformities. So the probability of finding one or fewer non-conformities. So your sample space corresponds to sample space corresponds to the non-conformities. For example, it can take numbers like 0. 0 means there is no non-conforming items, which means that all are conforming when you do a testing of 50 samples. 1 means there is only one non-conforming item. 2 means there are 2 non-conforming items out of 50, and so on, and the maximum is 50, which means that all the 50 are non-conforming. Okay, so that is the meaning of this one, and this corresponds to my sample set. It's not sample, it corresponds to my random variable. Okay, so this is my random variable, and you can see that this is a discrete random variable because it can take only integer values. So it's a discrete random variable, and my sample space is 0 to 50. So there are 51 numbers possible, right? I hope it is clear. So the sample space is nothing but your non-conformities. 0 means there is all the products, all the samples which are tested are conforming to the specification. 1 means one sample out of the 50 is non-conforming to the specification. So it's non-conforming. Okay, so it's related to non-conforming. That I have treated it as access. Okay. So find the probability of finding one or fewer non-conformities. Okay, so this is my random variable x. Find the probability of finding one or fewer. So one or fewer, you can put less than or equal to. Less than corresponds to fewer, and equal to corresponds to 1, equal. Okay, so probability of x less than or equal to 1, that is what you need to find out. So if you see this from the given conditions, you can identify that the distribution is binomial because the sample space is fixed, and you have the probability of success which is given, and that is actually a constant. So you can consider this as a binomial distribution. So in the problems, it may not be directly given whether the distribution is binomial or not. You may have to identify. So that is one job you have, but once you identify, then it is straightforward. For identifying binomial distribution, it is always better to look into the sample space. So once you look into the sample space, you can identify whether the distribution is binomial or not. And then what you can do is you can find out the probability for a binomial distribution, probability of a particular random variable for a binomial distribution by using the equation which we discussed in the class, which is ncx p power x q power n minus x. And here p is given, so q is also known. The p is 0.01, p is 0.01, so q is also known, it is 0.99. Okay, since why? Because q is 1 minus p. P plus q should be equal to 1. The sum of the probabilities, probability of success plus probability of failure, should be equal to 1. Okay, so this information also we have. Now we have to find out for probability x less than or equal to 1, which means that probability of x is equal to 0 plus probability of x is equal to 1. Since these are discrete distributions, we have to we will take the sum. Okay, so that is important point here. So since these are discrete distributions, we actually take the sum. If these are continuous distributions, these need not be sum. It should be integral. Okay. Okay, so since these are discrete distribution, or you can write mathematically this as sigma x is equal to 0 to 1 ncx p power x q power n minus x. So this way you can write it. Sigma notation comes for discrete distributions, or summing you do when you have discrete distributions. Now I know my n, x and p and so on, so you can just simply substitute it. Probability of x is equal to 0, that is what I am writing down. So that is nothing but 50 C0, P is 0.01 raised to 0, and Q is 0.99 raised to 50 plus 50 C1 point, that is corresponding to x is equal to 1. This is corresponding to x is equal to 1. So 50 C 1.01 raised to 1 and 0.99 raised to 50 minus 1. Okay. And 50 C0 is nothing but 50 factorial divided by 0 factorial into 50 minus 0 factorial, and 0.0 power 01 raised to 0, anything raised to 0 is nothing but 1 into 0.99 the whole power 50. You have to find it out. Just see, is 0.99 the whole power 50, and that comes to 0.6050. Okay, plus 50 C1, that is nothing but 50 factorial divided by 1 factorial into 50 minus 1, which is nothing but 49 factorial. 0.01 the whole power 1 is 0.01, and 0.99 the whole power 49 is 0.6111. Okay. Now you have to solve it. 50 factorial divided by 50 factorial, this gets cancelled out, and 0 factorial is 1. Remember this, 0 factorial is 1, so this will be 1. 1 into 1 into 0.650, 6.6050. Okay. And this one is 50 factorial is nothing but 50 into 49 factorial. Right, this is 50 into 49 factorial. So this 49 factorial get cancelled, so you got 50 there, multiplied by 0.01 into 0.6111. And if you write this one, that is 0.6050 plus 50 into 0.01 into 0.6111, that will be 0.3055. Okay, so this gives you plus 0.6050, that gives you 0.9105 or 6. Okay, so that is what you will get, and this is the probability of finding one of your non-conforming parts. So I will write it down. So the probability of finding one or fewer non-conforming parts I represent in terms of percentage, so it becomes 91.06. So there is a 91% probability of finding one or fewer non-conforming parts. So that is all. I hope it is clear now. You can do the tutorial problem also. If any doubt, please let me know.